All right, guys, what questions do you guys have?
Number 2.258.
2.258. Was this a homework problem? Okay. Yeah, just know that the homework problems I've uploaded solutions for on Canvas. We can still do this one, but yeah, it's uploaded already. Feel free to ask homework problems, but also problems that aren't on there. So, you know, you're not just getting more of the same stuff. Yes, ma'am.
So like the homework questions that we were given from each section, will those be the ones that'll be like on the test? Like, will they only come in the sections that we have homework questions in? Or
Yeah.
Like
Yeah. So test 1 will be over chapter 1 and chapter 2.
Yeah.
I'm not going to put chapter 7 stuff on test number 1.
I feel like there's like sections that we didn't have homework questions from, like in each chapter.
Oh yeah. Okay. You mean in the homework, there's like, you know, concepts and vocabulary or whatever. Okay. Yeah. I have to say that all the content is fair game.
Okay.
But the stuff that I ask questions over, that I put homework assignments over, might be more relevant than the stuff that I didn't.
Yeah.
So I'm not gonna like ask you vocabulary questions like number 2, like to solve it, to blank a triangle means to find the measure of all blank. No, I'm not gonna do that. This isn't high school. I'm a mathematician. I'm not a fill in the blanks kind of guy. I'm a let's solve problems. Let me see how you guys are using your brains. And so it's 9:27, and so class has already started. So I'm expecting all technological devices to not be visible by me. Okay. So yes, we can do that problem you wanted to. I'm just saying it's already solved. But because you asked, I'll do it. Okay. So we have a parallelo pipette. What is that, right? A parallelo pipette is just a rectangular box. So this is 70. This is 50. This is some H. And then there's this diagonal, which I'll signify in a different color. It goes from that corner all the way down over here. And it makes some angle theta. The question asks, find the height H that ensures the diagonal across the middle of the box will be 90 centimeters. So find this H that ensures that the diagonal that goes across the middle of the box, let's call that D, capital D. Ensures that that value is equal to 90 centimeters. Okay. So what is the value of theta that will ensure that? So what is the H? Wait, hold up. A, find the height H that ensures that the diagonal is 90. Okay, find the height h that ensures that that diagonal is 90. Okay, so notice that this height right here is the same as this height. Okay, if this is diagonal capital, we'll call this diagonal lowercase. All right, notice that we could create a triangle here. Bring this triangle out. I can say that this is 50, and I can say that this is 70. I can say that this is a right angle, and I can say that this is lowercase d. Now we can find lowercase d, can't we? How? Which states what?
50 squared plus 70 squared equals d squared.
So that means d squared is what?
Your answer is going to be 86.
Oh, you did it for me. $86. Oh man. So this distance is 86 centimeters. Okay. But the question isn't asking for lowercase d. It's asking what is the h so that this capital D will equal 90. We're just finding what lowercase d is because now we're going to create this triangle. That triangle is this. Okay, well, we know lowercase d is 86 because this young man revealed that to us. We don't, oh, and we also know what capital D is. So what is h? How can we find it?
X squared plus 86 squared equals 90 squared.
We use the Pythagorean Theorem. 90 squared is equal to h squared plus 86 squared. That implies h is equal to the square root of 90 squared minus 86 squared, which you said approximates to what?
It's going to be 17.462.
Are you sure?
Oh, no. Hold on. It's going to be 26.533.
I like that better. So we get h is approximately 26.5 centimeters. Does that make sense? You have to realize that there's a triangle down here and that you have to solve for this lowercase d first in order to construct this triangle up here. If it's difficult to visualize, create a little paper box and cut out a little paper triangle and put it in there. You'll see what I'm talking about. It's like a pizza in a box or a piece of cheese. Now I'm getting hungry. So then the part B says the angle theta that the diagonal makes at the lower corner of the box. What is it? And class is in session, so all electronic devices should be not visible by me. Calculator is fine. Your brain is fine too, because your brain is an electronic device. Test on Thursday. So we're reviewing for our test. So what is theta? I erased the triangle. We have this triangle where this is h, 26.5. And okay, we have this, which is 90. Here's theta. That's all the info I need, really. I want to know what theta is.
Don't you need the 86?
Huh?
Don't you need the 86?
Oh, is this 86? Sure.
I found the cosine of theta.
Cosine of theta would be what?
It's going to be 86 over 90.
Why?
Adjacent over cosine.
That's it. You could have used the sine of theta. You didn't have to get 86, but it still works. Same thing. Your calculator will spit out the same value. How do we find theta? That's what we want. Cosine inverse is both sides. Cosine inverse hits this, it just turns into a theta, but it sticks here. You just stick this into your calculator here, and it gives you that theta is approximately
17.46.
yeah, approximately like 17.1 degrees. Make sure that your calculator is in degree mode. If you want it to input degrees and output degrees. Your calculator has two modes for angles, degrees and radians. Make sure that it's in degrees. Any other questions? If you guys run out of questions, I'm going to move on to new material, chapter 3 material. I have the solutions to all of your homework problems uploaded on Canvas, so you guys can look at that. But yeah, we lost like 2 weeks. I will gladly move on if you guys don't have questions. But I want you to ask questions. I want you guys to do well. So I'm here to serve your needs. If you don't have a specific question, like number 5 on page 36, you can ask about a concept, like, hey, can you explain this concept? That's fine. I'm gonna let it slide this one time. Any concepts that you guys need fortification with? Yes, ma'am.
Can we do 1.3, like 73, or number 73, and
1.3, I'll do both of them. 1.3, number 73.
Shit, yeah.
Okay, let's see what this says. 73. For each exercise, state the quadrant of the terminal side and the sign of the function in that quadrant. Sine of 719. It's not very obvious which quadrant that's in. But we can utilize the fact that if you do a 360 spin, you land in the same spot, whether you spin clockwise or counterclockwise. So this is the same thing as this. Is it not? So what is 719 minus 360? Huh?
Yeah, I think it's
359? I know what quadrant that's in because it's within the realm of 0 to 360. So what quadrant is it in? Quadrant 4. What's the sine? No pun intended. What is the sine? Is sine, what is the y values in the fourth quadrant? Negative. Aha. So sine is negative. And you said, young lady, you said 73 and 74?
Yeah.
What does 74 say?
cosine 528.
Utilizing the fact that adding or subtracting 360 degrees lands you in the exact identical same spot. What's this minus 360? 268? 168? Okay. What quadrant is that in? What's the sign of cosine? In quadrant 2, what are the x values? They have a negative on them. Right? Because in quadrant 2, they're to the left of the y-axis. So x values will be negative there. Does that make sense?
Yeah, I just don't remember this, like, for some reason, I just, like, blanked. Like, I don't get the whole quadrant, like, how you knew 168 wasn't 2. Like, what's in quadrant 1?
Great question. Quadrant 1 consists of the angle values 0 degrees to 90 degrees. Anything in between 0 to 90 degrees is in quadrant 1. After that, anything that's in between 90 and 180 degrees is in quadrant 2. Anything that's between 180 and 270 is in quadrant 3. Anything that's in between 270 and 360 is in quadrant 4. That's correct.
But if it's above 360, that's when we subtract 360 from the number that they give us, like on the first one.
Yeah, because it's kind of hard to guess what quadrant is that in. What quadrant is that in? It's hard to guess.
Yeah.
Definitely hard for me to guess. So I subtract the 360 or add a 360. Let's say you were given, what is the cosine of negative 1,000 degrees? Just add enough 360s to make it a positive angle. How many 360s do we have to add to that? Let's do 3 360s. Cosine of what? Three times 360 is what?
1080.
1080?
Yeah.
So that means this is the cosine of 80. Right? So what quadrant is this in?
One.
What is a sine?
Positive.
Correct. That's how you do it. Does that make sense? Very good. Good job. What else?
This one is like way beginning. The coterminal angle, positive angles, and negative angles.
Mm-hmm.
But I just don't get it.
You don't get it? Be prepared to get it.
Three.
Oh, 1.3.
No, basically.
Okay.
Be prepared to get it. Coterminal angles. You just want me to explain what that is?
Yeah.
Could
Yeah,
you
with-
do practice problems?
Yeah, I'll just invent some. Yes.
Are we gonna be able to turn up in the set?
Are you gonna be able to what?
You turn up to the set.
No. No. Maybe a note card or something. You can use a note card, an index card or something. Yeah, if that makes you sleep better at night. I got this index card. I'm gonna cuddle with it.
I can write small, actually.
It does? Well, good. Well, good. Sleep is important.
Like this thing?
Sure. Yeah, that works. So coterminal angles. So conceptually, well, if you're gonna give it to them, you might as well give it to everybody in the class. There's this young man over here. He didn't get a card.
I got one.
Oh, you got one? This lady didn't get a card, and this young lady didn't get a card.
I got it.
All right, let's make an Oprah status up in here. All right, let's talk about coterminal angles. Let's say you have some angle. How do I make this simple? 40 degrees. A coterminal angle is an angle that lands in the same spot as 40 degrees. So I could say that this angle, 40, is coterminal with the angle 400. Why is that so? Say that louder, young lady.
Because you added 40 to 360.
And why did it land in the same spot?
Because you went around in a black circle.
Yeah, it's as simple as that. So 40 and 400 are coterminal angles. Given any angle theta. You can add or subtract 360 degrees. This is theta minus 360. That's a coterminal angle to theta. For example, go in the reverse direction. So rotating counterclockwise is like adding an angle. Rotating clockwise is like subtracting an angle. So what would the red angle be? It would be your initial angle 40 degrees minus what? 360. This gives you what? Yeah. So to 40 degrees, negative 320 is coterminal. And to 40 degrees, positive 400 is coterminal. It's as easy as that. Yes?
On page 7, can you do, like number 39 or 30?
Yes, your wish is my command. I'll do 39 and 40.
Okay.
What does 39 say? Theta is equal to what?
4.5.
Just find the coterminal angles to measure between negative 180 and 180.
Find a coterminal angle to that measures between.
Negative 180 and 180.
Okay, so we want theta to be within this range. What can I do to this number? If I want it to be in this range, do I want to add a 360 to it? What do I want to do to it? Subtract the 360. Gives you what? 65? Is 65 within the range of negative 180 to positive 180? Done. Your perplexed countenance makes me concerned. Does that make sense, or do you have a question? Make sense? Okay. 40, what does 40 say? 494?
495.
495? What are we going to do to it? Yeah. Which equals what?
35.
Equals what?
35.
35?
135.
135. You got to enunciate, man. I just hear like, you know, you got to, yeah, enunciate, talk a little louder. I know I have good hearing. I don't have good vision, but I have really good hearing. At least I think so. Yes, ma'am.
I understand how to do this, but I just want to like clarify. Were you going for a decimal degree to DMS?
Yeah. Decimal degree to to degree in minutes and seconds. Do you have a concrete example you like to do in the book, or you want me to make one up?
I can give you one.
Give me one.
67.307.
Something like this.
Yeah.
We want that in degrees, minutes, and seconds.
Yeah.
Okay. So this is equivalent to. Is it not? Well, we just leave this alone because it's a pure degree. This is what we want to decompose because it's something that can get smaller. It's not a whole degree. All the whole degrees are here. These are decimal degrees anyways. And the minutes and seconds are values that are smaller than a degree. So that's why we're going to actually pay attention to the decimal parts of the degrees, because that's the only thing that's going to give us a minutes and a second. Okay? So in 1 degree, how many seconds or how many minutes do I got? Why did I put this here? Because we want to cancel the units. Make sense? So now your value is in pure minutes. So what is 0.307 times 60 in your calculator? And enunciate when you say the number.
You
How many?
didn't get the number.
18.42.
18.42?
I think, yeah.
Is that what you got?
Yeah.
I got something else.
What did you get?
921 over 15.
Now you're gonna have to make me do it. Now you're gonna have to make me do it.
I gotta see what you do.
18.42 wins. Okay, so then notice that 18.42 minutes is the same thing as 18 minutes plus 0.42 minutes. This is a whole minute. This is a decimal minute. So let's decompose this to seconds. And 0.42 minutes in 1 minute, how many seconds are there? So we cancel out this unit and we get 0.42 times 60. 25.2. Thank you, everybody, for verifying. So 67.307 degrees is the same thing as 67 degrees, 18, and what else? If you don't give me something in 30 seconds, I'm moving on to the new material. "25 seconds. "20 seconds.
People of number 7 from 2.2.
All right. Number 7 on 2.2. Solve each triangle using trig functions of an acute angle theta. Give a complete answer. So 7 is this triangle here. Oh no, that's the angle. EA 196. Solve each triangle using trig functions. So we want to know, this is little b, this is capital B, this is little a, this is capital A, this is little c, this is capital C, little c. There you go, okay. So what is capital B? How do we know that?
I mean, we get to do that 180 minus 90.
Yes. Equals. So yes, this is 60 degrees. We're on our way to solving the triangle. Now we got to find out what is little a and what is little b. Gave you a hint, said use trigonometric functions.
Can you use a sine of sine of 60?
Yes, I'm
Which is what? So how do I find b? By what?
That'd be almost right. No, 17, no, 97.
So what does that mean? B is approximately. I'm gonna double check you guys.
3/2.
Yeah, but
You actually enunciated that one. I'm proud. So when I got 196 times sine of 60, yes, sine of 60 is square root of 3/2. So it's square root of 3/2 times 196, but it's the same as 169.74. You can approximate that to 170.
So do we have to use sine of 60? Do we use like cosine?
That's an excellent question. You could have achieved that same value utilizing cosine. Well, cosine of what? Cosine of what? Cosine of 90.
never mind, sine of 90, that's good.
Sine of 90.
Never mind. Yeah,
Sine of 90 is 1. That doesn't have any of our unknowns in it. Cosine of 90 is 0. That doesn't have any of our unknowns in it. We want to solve for one of these unknowns. Huh? Huh? Tangent? No, we want to try to use cosine. So cosine of what? It's not 60 and it's not 90. Yeah. So cosine of 30 is what? Which is what? Over what? Which is your hypotenuse. Multiply both sides by 196. This should equal your B. And you put that in your calculator, I guarantee you'll get approximately 170. It's like 169.7. Do it. Everybody do it. Do 196 times cosine of 30. Which cosine of 30 is root 3/2.
190.
169.
Yeah, 169.
Yeah, I got a little bit of that.
Yeah,
Yeah, I got a little bit of that too. Okay, so you could have used cosine, that's right. You could have used sine, that's right. But we only solved for B twice now. We're not done solving the problem. We also want to solve for A. Little a. If you're going to make a suggestion, make it loud enough so I can hear.
930 degrees of Fahrenheit.
What does this equal?
A over 100.
Which one is it?
170.
Why is it 170? Adjacent. It's definition of tangent. Tangent is opposite over adjacent. So then we can solve for the tangent by saying, or we can solve for A, I mean, by saying that 170 tangent of 30 degrees is equal to A. Notice that the tangent of 30 degrees analytically is the value of sine over cosine. Sine of 30 is a half. Cosine of 30 is root 3/2. When you multiply by reciprocals, you get that this is 1 over root 3. And whenever you rationalize, you get this as root 3 over 3. But you don't have to do any of this. You can just plug it into your calculator and you should get what?
98.
98.14.
98.1. Yep. Yes, ma'am.
The step you did right before the 98.1 is Are we gonna need to do that on the test for credit, or can we just plug it in?
It depends. If I say leave your answer in exact form, this is the right answer.
Could you walk me through that step again? really quick?
Why not? Since you asked so nicely.
Thank you.
The tangent of 30, tangent by definition. Tangent of 30 degrees is by definition the sine of 30 degrees divided by the cosine of 30 degrees. Okay, but what is the sine of 30 degrees? I taught you guys a unit circle. You should know this by now. What is the sine of 30 degrees? It says it right there.
1/2.
You should know this by now. What's the cosine of 30 degrees? Yes, you should know this by now. You guys should be able to derive the unit circle by now and reproduce all the special angles and assign the cosine and sine values at all the special angles. That needs to be understood. When you multiply top and bottom by the reciprocal, you get this. I heard a cell phone call. Better get that. Told you I have good hearing. Those two cancel. And this equals 1 over square root of 3. Then you rationalize the denominator by multiplying top and bottom by fancy number 1, because anything divided by itself is 1. Root 3 times root 3 is root 3 quantity squared. Whenever you square a square root, it becomes just the number inside the square root. So the denominator is just a 3. The top becomes a root 3 because anything multiplied times 1 is itself. So that's why the tangent of 30 got replaced with root 3 over 3. And that 170 came along for the ride in the computation. Any other questions? You have 30 seconds. $25 seconds.
Um,
20 seconds.
Can you do an angle of depression?
Yeah. Professor Niazi. Is on a Kawasaki Ninja motorcycle and is about to drive off a cliff. For fun into a meadow. The height of the cliff is known to be 100 yards. Now this is working meters. If we project a straight line, we get this dashed line. We say that the angle of depression of me and, let's say, this rock I want to avoid, as opposed to a straight line, this angle of depression, let's say, is 30 degrees. Because it's the angle that deviates from flat down, and therefore it's called depression. Okay. How far is it from the meadow and the base of the cliff?
you subtract 90 from 30, right?
Subtracting 90 from 30 to get what? Yes, that's right. Because this total thing is 90 degrees. If you subtract 90, if you subtract 30 from 90, you get 60, right? So we can say that this angle here is 60 degrees. You're absolutely correct. All right, now what? This one?
Yeah.
How do you know that?
Because the 30, 60, 90 triangle.
Yes. A way to prove it is to say, okay,
Oh, yeah.
180
Minus 60 minus 90.
should be 30. That's how you can prove it. Okay, now you know it's a 30, 60, 90 triangle. What is this distance from the meadow to the rock that I'm trying to avoid?
You say cosine of 60,
Which equals what?
100 over h.
Cosine of 60 equals what?
100 over h.
Over h.
I mean, hypotenuse.
Okay, but even if you solve for the hypotenuse, we want to find capital D, not the hypotenuse. Of course, if you do this, then you could utilize the Pythagorean Theorem. Your solution method can still work out. But why not do it sooner, you know? It's in preparation for an exam, you want to do things as fast as you possibly can, right? So there's a faster way than this one. What's the faster way?
Sine of 60.
Which one is it? Sine or tangent? No, it's tangent. Because sine, it's tangent because sine still uses the hypotenuse. Tangent doesn't use the hypotenuse. Tangent of 60 is opposite, which is what? What we're looking for over what? A value that we know. We know. So we know two of the values. We can solve for a third unknown value by multiplying both sides by 100. So we get 100 tangent of 60, which is equal to what? I gotta check you guys. $173.2 meters. So that's this distance here. Okay. I'll take that into account as I'm driving off that cliff. I got nitrous oxide in my Kawasaki Ninja. So I'm just gonna hit that NOS right here. And I'm probably gonna land right there and I'll be fine. $25 seconds. Okay, what is it?
Will we have to do that stuff? Like that's on the board?
Did we talk about that in class?
Little confusing.
Did we talk about any of that stuff on the board in class? Well, so what do you think?
I just want to know.
You want to know about it?
No.
What math is that?
That looks like calculus.
Is that the same as applied calculus or whatever?
I don't really know.
I just take that.
That's good. You should take all calculus. You should take all calculi. Calc 1, Calc 2, Calc 3, linear algebra, differential equations. Then you could take abstract algebra, topology, real analysis, complex analysis, differential geometry, algebraic topology. You just want Calc 1?
Well, no, in Texas, if I want to go to medical school in Texas, they only.
Why do you want to go to Texas after what happened?
I mean, that's fair.
Chill. That's much of my state.
Is Texas your state?
Yup.
I feel bad for you, man. Oklahoma's my state.
I'm from Kansas, and I ain't gonna defend it. It's pretty boring.
You're lucky you were here.
True.
Yeah, uh-huh. You're not getting $15,000 monthly electric bills. Although that might still happen to us. Yeah. So any questions about review, or else I'm gonna move on?
Oh,
Yes, ma'am.
under, in 2.4, number 51.
2.4, number 51. Evaluate an exact form. Sine, okay, I'll just let you tell me all of them. One of them is sine of 120, right?
Yeah.
Yeah, you should be able to do this for sure.
Okay.
What is that? We have to go to the unit circle. Where is 120? What quadrant?
2.
Yes. Recall the 30, 15, 15. 30 rule. 30. Add a 15 to that is 45. Add a 15 to that is 60. Add a 30 to that is 90. Add a 30 to that is what? So what is the sine at that value? That's asking you what is the value of the y? This right here. It's positive, that's correct. But what is this numerical value? I'll tell you the cosine and sine respectively here is 1 and 0. Cosine and sine respectively here is root 3 over 2, 1/2. Cosine and sine respectively here is root 2 over 2, comma root 2 over 2. This should be like, you should know this. You should definitely know this by now. This should be 1/2 root 3 over 2. And this ends up becoming 0 and 1. So what does this become? Why? Why is it negative 1/2?
Because the x's are negative.
As you go the y-axis to the left of it, the x's become negative. Yes. And what is the y? Because our answer depends on what sine is, and so the y is what we're looking for.
So square root 3 over 2.
Very good. So what is the sine of 120?
Square root 3.
Yeah. What's the next one?
Cosine negative 240.
Cosine negative 240?
Yeah.
This is the same thing as what? Yes. I wrote an epsilon instead of a 3. Which gives you what? 120? How serendipitous. We already put the value of cosine of 120 up there. So it should equal what? There you go.
And then tangent 480.
Say what? Yeah. Which equals what? 120. Equals what? One half.
Negative.
Negative 1/2.
It's the same thing, right? So it would be.
What is the definition of tangent?
Opposite of,
Sine over cosine.
yeah.
It is opposite over adjacent, but it's sine over cosine as well. Definition of tangent of 120 is sine of 120 over cosine of 120. So now what?
Square root of 3 over 2 over 1.5.
Is this right? No. What?
Should be a negative. Right?
Aha. Apparently Texans need to speak louder as well. Now what?
When the two's like.
The unit circle can come back later. You multiply by reciprocals here. So the 2's cancel, but the negative still remains. Negative didn't cancel. So this is your answer. Negative square root of 3 is tangent of 120. Does that make sense? Yeah. No. Just know that this is the definition of tangent, because tangent of theta is sine of theta over cosine of theta. Just replace theta with 120. The reason tangent is opposite over adjacent is very simple to explain. Because sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse. When you multiply by reciprocals, you get opposite over hypotenuse times hypotenuse over adjacent. Hypotenuse cancels and you get opposite over adjacent. That's why. But this is not useful in this context. The sine over cosine is. So you guys have to know how to like use what you're given in the various situations. That's why a note card is not going to like save your life on this test. Knowing the mathematics is what will be important. 25 seconds. Fifteen seconds. 10 seconds. 8, 7, yeah.
This one is just like a calculator problem, but 2.2. Could you do number 17?
Sine of 27. Just put it in your calculator.
Okay.
Yeah. Do it. What do you get?
0.5990.
0.43,
0.53.
0.4, what?
Oh wait, 0.4539.
That works. Yeah, it works. Don't forget, it says rounded to 4 decimal places. So how would you round your answer up?
It would be 0.454.
That's correct. $25.
Can we do like number 13 on 1.3?
Mm-hmm. 1.3?
Yeah.
13. Okay. -5/8, 3/4. Here's our point. On x as -5/8. On y as 3/4. So this point is located right here. Right? So we can make a triangle out of that. Bring this down, make a right angle. This is some angle theta, we don't know it yet. But this value is 3/4, and this value is -5/8. So I can make that bigger. It's the same thing, I'm just scaling it up. Write the equation of the line coincident with the terminal side of the non-quadrantal angle containing the point. Include the domain restriction and quadrant of the terminal side. So what it's saying is find the equation of this line here. This line is equal to some y equals mx plus b. We already know what the b is. What is it? That's the y-intercept. But it's going through the origin, so the y-intercept is 0. So the function is just equal to some y equals mx, where m is a slope. How do we find the slope? The slope m is equal to y2 minus y1 over x2 minus some x1. We already have some x2, y2. What's our x1, y1? These are two different points that are on the line. I know for sure this -5/8 and this 3/4 is on the line, but I also know that this origin point is on the line. The coordinates that parameterize the origin are 0, 0. So this equation reduces to y2, which is -0, divided by x2, which is, okay, so this becomes 3/4 divided by -5/8. Multiplied by reciprocals, and you get 2/4 multiplied by -8/5. 8 is really 4 times 2, so the 4's can cancel. So this becomes 3 times 2, which is 6/5 with a negative on it. -6/5. And this is our slope m. So our line y is equal to -6/5 x is equal to our y. Write the equation of a line coordinate with the terminal side. What is the quadrant of the terminal side? 2. What is the domain restriction?
Negative x equals 0.
Really, you don't need it. There is no restriction. The domain is negative infinity to positive infinity. Because this line is defined everywhere. So the line can extend forever. That's just a technical point. $25. $20.
What does it mean for theta to be in the standard?
Say that again.
What does it mean to theta be in the standard position?
Excellent question. What does it mean to be in standard position? So we have our xy coordinates, and let's say we have some angle theta. Here's the initial leg right here, and here's the terminal leg, right? Standard position is not that theta. It's this right here. Call it alpha. Because standard position is the angle that is formed with the x-axis that is acute. So an angle in standard position, notice that theta represents this terminal leg, but also this terminal leg with the alpha over here represents it as well. Where clearly they're supplementary, so alpha plus theta do equal 180. But we take the smaller one to be the standard position. So for example, let's say we go 120 degrees. That's when we determine that the cosine is negative 1/2 and the sine is √3/2, right? But we didn't have to evaluate. So we said cosine of 120 is like negative 1/2, for example, and that the sine of 120 was √3/2. But we didn't have to do that. If we talked about the angle in standard position, what's this angle right here? Huh?
60.
60. So this y is the same thing as sine of 60. And this x is the same thing as negative cosine of 60. Why did I put that negative there? Because of what?
All the
Or your x is negative, yeah. That's why you put negative cosine of 60. It's in the second quadrant right here. So that means that's equal to negative cosine of 60 was 1/2. So that's an angle in standard position. We can represent that angle as a rotation from the starting point by 120. Or we can say it creates this triangle where this angle is 60 degrees. So let's say I have an angle 260 degrees. What is the standard position angle? Right here. What is the acute angle it makes with the x-axis? $80. Yes. Because the other angle it makes is not 80. It's 120. So we take the acute angle. Does that make sense? Any other questions? Well, you're free to go then. See you on Thursday. You can have a note card. Don't think that note card will save you. You need to be practicing. I've uploaded solutions for all of the homework that's already due. It's on the Canvas file tab. So that should give you more resources as well.
We sent the homework by email. Do we have to turn it in?
Nope, you get 100. If you turned it in, you get 100. If you don't turn it in, you don't get 100. So turn in your homework if you want to get a grade. You either get a 0 or you get 100. The test is where I'm really going to see what you know. Your grades will mostly be dependent on the tests. You should do all the homework to help buffer the tests because the tests are worth a lot.
Is it a long test?
No, it's just a test that can be completed during class time.
Yeah, that's my question.
I'm gonna go study.
Thank you.
I just